Hi, this is Jordan for ItDev 154, assignment 6 about hash tables. This is my very simple addition for a hash table. So, hash tables are created via structures. They can have multiple points of data per um, hash, I suppose is the best way to describe it. Um, So for this one, I have two things. I have the user ID, and then the user name, um, and that's how it goes. Um, so this is the constructor user for the user info. Um, it needs to be. I found out it was weird when I was doing this. So if you don't have your two things put in, it'll create an error. Um, so that's that. Um, I will say that this is probably my favorite of the data structures. It seemed very easy to implement and wasn't something that made my head hurt. There are two um, structures here. There's a list and a hash table. There's a reason for this, and I'll show you a little bit later. But this is how you create a hash table. So you have a static hash table, and then you title it. So for mine is titled user info hash. This stopwatch is part of something later, and I'll explain it when I get down there. So um, you create your new hash table same way as you do every other data structures. Um, this is how you add. This 4 million iterations is something is again related to the stopwatch, so ignore this for loop repeating 4 million times. You simply add. So your data structure dot add, and then you put in the information. In this case, it's going to add the I value and the user plus I. So it's going to assign it. So, for example, in the first iteration, it'll be in the first section of the hash in the first hash, it'll be 1. That will be the user ID, and then the string will be user and then plus 1. To remove it, it is removed via the key. And so how it goes is you remove certain keys. So in my instance, my key would be this I. So if I wanted to remove that first user I talked about, I would put in 0, because that's how programming works. It works from 0 upwards. So I would put in 0 and would remove the beginning user. It first also does check to see if it contains a key. So this is how you set values. If the hash contains the something in the position, then it will replace user info hash, or replace the user with replacement name. This is commented out for the implementation of this, but I'll talk you through it. So this is how you get this is how you print out information in the hash table. Um, this is how you print out the whole table. If you want to print out specific ones, then you would use console write line, um, entry key, and then entry value for for this specific table. Um, but this is commented out because with 4 million iterations, it would cause problems. So this is to show. So what this is it compares the access times between a list and a hash table. What it will do is it randomizes a number between 3 million and 4 million. So obviously it's going to have to iterate through the million objects in order to get to that, but it happens quite quickly. So this is a really good data structure if you need to access large sets of data very quickly. So we'll run it. Hold on a second. Okay, sorry about that. Please excuse that error. The original version of this was written on my Mac, and Mac uses framework dependencies. So all I did in the meantime was I literally copied from the top to the bottom this code over to a new Windows-based project. I needed to add this console.read key, otherwise it instantaneously exits out without showing this input. So if I run it, this cycle runs. As you can see, from the list, usually takes in the milliseconds between 11 milliseconds and 16 milliseconds, whereas the hash table is almost instantaneously. And these numbers are randomly generated. So it's clearly showing that the hash table has a quicker. During this time also as well, there was a removed. We can uncomment it out and iterate it. I'm pretty sure my computer won't explode from doing this. So let's do it real quick. Might take a minute. Yeah, so this is that method, and it's clearly going to take a minute even with a decent computer. So it's displaying the key for it, and then it's displaying the key, which is how you reference certain points in the hash table, and then the value of that key is the word user and then the number. So this is how it goes. That's all I really have for hash tables. There was a hash table removed. The very first hash table was removed. Actually, it's not quite happened yet because it's still processing, but we can stop it real quick. We can lower the iteration to 1,000. We can include a console.writeLine to state that key was removed. Just to display that it actually is removed. So the key at 0.0 was removed. So it did actually removed it, and then it iterated it 1,000 times. And then, whoop, sorry. This failed because there wasn't 4 million points of data. And obviously you can show that down here that key value, the value at 1. So 0 is missing because it was removed. And then key 1 was replaced with replacement name, just to show that it does in fact work. That's all I really have for hash tables. I kind of look forward to using them as they seem to be the less hectic version of the data structures. That's all I have.